From the moment we open our eyes and see the sky, the ground, the rivers and the mountains, it's easy to believe Earth is permanent, unshakable, and endless. Yet the truth is far stranger and far more unsettling. This planet has been everything but stable. It has been forged in chaos, sculpted by fire, drowned in water, and shaken by forces so violent that entire ages of life have come and gone without leaving more than a trace. When we speak of Earth, we're not just speaking of a world that hosts us comfortably today. We're speaking of a planet that has survived collisions with other worlds, frozen over entirely, burned with global volcanism, and wiped out species with casual indifference. Earth has been both cradle and executioner, both sanctuary and destroyer, and its story is filled with revelations that most people have never been told. Think about it. Every stone, every grain of sand beneath your feet is older than humanity itself, forged in cycles that span billions of years. The continents you see on a map were once fused into a single massive landmass, only to break apart and drift like rafts across the ocean. The air you breathe, rich with oxygen, is not something Earth always had. It was created by tiny microbes in an event so catastrophic it nearly ended all life before it had even begun. What we consider normal about Earth, the blue oceans, the breathable atmosphere, the rhythm of seasons, is a fragile illusion, balanced on geological and biological systems that have collapsed before and can collapse again. And yet, this is the part most people miss. Humanity is not just living on Earth anymore, we are changing it. The burning of fuels, the cutting of forests, the rise of machines and technology have shifted the balance in ways the planet hasn't seen in millions of years. For the first time, one species has grown powerful enough to rival volcanoes and asteroids in shaping Earth's future. But if history tells us anything, it's that Earth doesn't wait for anyone. It adapts, it resets, it moves on. The real question isn't whether Earth will survive, it's whether we will. To imagine Earth's beginning, you have to strip away everything familiar, the oceans, the skies, the forests, the continents. Picture instead a young star burning in the emptiness of space, surrounded by a swirling disk of gas, ice, and dust, left over from the violent birth of the sun. This chaos was no gentle nursery. It was a cosmic battlefield where particles collided, clumped and shattered apart again in a relentless process that lasted millions of years. From this spinning cloud of debris, planets began to take form. Earth was not born as the calm, life-filled world we know today. It was forged in fire, hammered into existence by collisions, so fierce that each one could have annihilated everything we now take for granted. If you stood there in those first 100 million years, you would not see a blue marble, you would see a glowing sphere of molten rock, wrapped in choking gases, scarred by impacts and anything but habitable. The early Earth was a world of extremes, where survival itself was in question. One of the most violent events that defined its birth was the collision with a Mars-sized object we now call Theia. This wasn't a small strike, it was a planet-scale crash, so powerful it melted much of Earth's crust and blasted enormous amounts of debris into space. From that fiery wreckage, the Moon was born, its fragments pulled together by gravity to become Earth's eternal companion. Imagine the sky after that event, red-hot rock and vapor circling above, glowing brighter than any sun, eventually cooling into the Moon we see today. Without that collision, Earth might have remained a very different place, lacking the stabilizing influence of the Moon's gravitational pull that today regulates our tides and steadies our rotation. It's a reminder that Earth's very balance, the rhythm of day and night, patterns of seasons, may owe themselves to what at first seemed like pure destruction. After Theia, Earth did not settle into calm. For hundreds of millions of years, it was battered by constant bombardment from asteroids and comets. The surface boiled with impacts that carved craters larger than modern countries, releasing heat that kept the crust molten and unstable. Volcanoes erupted endlessly, pouring lava across landscapes that would cool only to be torn apart again. There were no oceans then, no life, only a restless world cloaked in toxic gases like methane, ammonia, and carbon dioxide. If you could stand on Earth at that time, you wouldn't survive a second. The air was unbreathable, the heat unbearable, and the ground unstable beneath constant upheaval. And yet out of this chaos, the ingredients of habitability were slowly forming. One of the greatest mysteries of Earth's birth is the origin of water. Some scientists argue it was delivered by icy comets crashing into the young planet. Others suggest it emerged from deep within Earth itself, released as steam from volcanoes and later condensing into liquid. However it arrived, it did not come easily. Early Earth was so hot that water would have boiled away instantly. Only after millions of years of cooling, as the planet's crust thickened and stabilized, could water settle on the surface, filling craters and basins to form the first ocean. Imagine the transformation. A world once blazing and hostile becoming a planet of shimmering seas, the very seas that would one day cradle life. But at that time, those oceans were alien, thick with minerals, dark and stormy, beneath a sky still heavy with poisonous gases. It was not the paradise we picture, but it was a beginning. The atmosphere itself was another product of Earth's violent birth. Volcanoes belched out endless gases, carbon dioxide, nitrogen, sulfur dioxide, forming a suffocating blanket around the planet. There was no oxygen, no blue sky, no ozone to shield the surface from deadly solar radiation. Instead, the sky would have glowed orange or red, heavy with haze, and storms would have raged endlessly. To us, this sounds like hell, but to Earth, it was essential groundwork. That thick atmosphere trapped heat, kept water from evaporating into space, and provided the chemical stew that would one day nurture life. What seemed poisonous was, in fact, preparation. Through all of this, Earth's core was working silently but powerfully. The planet's iron-rich heart generated a magnetic field that stretched into space, deflecting deadly solar winds that would otherwise have stripped away the atmosphere. Without that invisible shield, Earth might have ended up like Mars, dry, airless, lifeless. The same collisions and chaos that once threatened Earth also gave it the core and rotation necessary for this protective magnetic field. In other words, Earth's survival was never guaranteed. It was a matter of delicate accidents, violent events that destroyed and yet created. It's easy to forget that Earth could just as easily have failed. If it had formed too close to the Sun, its oceans would have boiled away like those of Venus, too far, and it would have frozen like Mars. If the Theia collision had gone differently, Earth might have been shattered beyond repair. If the magnetic field had failed, our atmosphere might never have survived. Earth balanced on a razor's edge, one lucky chance after another, to become what it is today. When we call it home, we're really acknowledging a cosmic miracle. And yet, even as Earth stabilized, it remained a dangerous place. Asteroids continued to strike. Volcanoes reshaped continents before continents even had names. Entire stretches of crust sank back into the mantle and rose again as new land. This constant recycling means almost nothing remains of Earth's first billion years. The record of its birth is mostly erased, hidden beneath younger rocks or lost entirely. What we do know comes from hints, tiny crystals older than any mountain lunar rocks that carry echoes of the Great Collision, and meteorites that mirror the building blocks of our planet. These fragments remind us that Earth's origin story is still incomplete, still mysterious, still filled with unanswered questions. When we look at the modern Earth, it feels stable, solid, dependable. But its beginning was a storm without end, a furnace that melted rock and rained fire. It was chaos that forged balance, destruction that gave way to stability. To understand Earth's fiery birth is to understand that what we take for granted, oceans, skies, even the moon itself, are not permanent gifts, but fragile outcomes of chance and violence. Our planet has never been gentle, and yet it has always carried the potential for life. Out of the wreckage of collisions, out of boiling seas and poisonous skies, the conditions for everything we know and everything we are was slowly assembled. And perhaps that's the most astonishing truth. Earth's story begins not with peace, but with fire, not with calm, but with chaos. And yet it is from that chaos that stability emerged. It is from destruction that creation was born. Without fire, without collision, without violence, there would be no seas, no atmosphere, no moon, no chance for life. Earth was not handed to us as a finished world. It fought to exist. It survived its own birth, and that survival set the stage for everything that came after. Oceans teeming with life, continents shifting like puzzles, civilizations rising and falling, and us here wondering how it all began. If Earth's fiery birth was the furnace that forged the planet, then the emergence of oceans and atmosphere was the miracle that made it habitable. For without water and air, life as we know it would never have stood a chance. But the way these two features came to dominate Earth's story is anything but simple. It is a tale of extremes, a series of near-impossible events where chaos gave way to balance. To imagine Earth in this stage, picture a world still smouldering from impacts, still scarred by volcanoes that split open the crust, still wrapped in gases that would choke any living thing today. And then, against all odds, something extraordinary began: the appearance of oceans vast and restless, and an atmosphere thick enough to shelter what was yet to come. The oceans may look eternal, but they were not there at the start. The surface of early Earth was far too hot to hold liquid water. Heat from constant asteroid impacts and the planet's molten crust made it impossible for water to stay. It boiled away as quickly as it appeared. But as millions of years passed and the bombardment slowed, the crust began to cool, and conditions shifted. Scientists believe the first water may have come from volcanic outgassing. Deep inside the planet, minerals locked away hydrogen and oxygen, and when volcanoes erupted, they belched steam into the air. Over time, that steam condensed and fell back as rain, not for days or months, but for thousands of years. Imagine a planet where the sky was endlessly dark with clouds, where lightning split the heavens and rain hammered the ground with relentless fury. Slowly, craters filled, basins deepened, and the first oceans began to take form. They were not blue, clear, or calm. They were thick with minerals, boiling hot in some regions, acidic in others, but they were oceans nonetheless. Another theory suggests that at least some of Earth's water came from beyond, delivered by icy comets and water-rich asteroids that crashed into the planet during its violent youth. Each collision released not just destruction, but the building blocks of sea, whether the water came from inside Earth or from the heavens above, or both. It is certain that once oceans took hold, they transformed everything. For the first time, Earth had the ability to regulate its temperature. Water absorbed heat, stored it, and released it slowly. It became a stabilizer, turning Earth into a planet that could nurture more than chaos. The oceans also became a crucible of chemistry, where elements dissolved, mixed, and recombined in ways that would eventually give birth to life itself. But the oceans alone were not enough. Above them, Earth's atmosphere was equally dramatic in its evolution. Today we take for granted that air is made of nitrogen and oxygen, but early Earth's skies were utterly different. The first atmosphere, born from the gases of the solar nebula, was light and fleeting, made mostly of hydrogen and helium. It didn't last long. The young sun blasted Earth with solar winds, so strong they stripped that atmosphere away completely. What followed was the second atmosphere, thick and suffocating, released by the same volcanoes that built the land. This atmosphere was loaded with carbon dioxide, nitrogen, sulfur dioxide, methane, and ammonia. The skies would have been orange or red, heavy with haze, with no oxygen to breathe, and no ozone to block deadly radiation. To modern humans it would have been poison, but to Earth it was foundation. The interplay between the oceans and atmosphere was vital. Carbon dioxide dissolved into the water, slowly reducing greenhouse effects and cooling the planet further. Meanwhile, volcanic activity continued to add new gases, constantly shifting the balance. Over time, the oceans and atmosphere worked together in a kind of chaotic dance, stabilizing the planet's climate enough to prevent it from either boiling over like Venus or freezing entirely like Mars. Earth was beginning to find its fragile balance, but it remained a dangerous world. Gigantic storms raged across the seas, lightning lit up the skies, and meteorites still fell from above. Yet within these storms lay the chemical sparks that would eventually ignite the story of life. What makes this stage so fascinating is how improbable it all seems. Venus, our sister planet, was similar in size and composition to Earth, yet it became a furnace of toxic atmosphere and crushing pressure, with temperatures hot enough to melt lead. Mars, on the other side, cooled too quickly, losing its magnetic shield and allowing solar winds to strip away most of its air, leaving it cold, dry, and barren. Earth, however, found a sweet spot. It kept its magnetic shield strong, retained enough atmosphere to hold water, and built oceans large enough to stabilize the climate. It is as if Earth threaded a cosmic needle, balancing on the edge of two extremes to become the only world in the solar system known to cradle life. As oceans deepened and skies thickened, strange processes began. Ultraviolet radiation from the sun struck the atmosphere, sparking reactions that created complex molecules. In the water, minerals dissolved from volcanic rocks combined with those molecules, creating a chemical soup that grew more complex with time. These conditions were not friendly by human standards, but they were the perfect laboratory for life. The oceans became the incubators, while the atmosphere provided both energy and protection. Without one, the other would have failed, but together they created the possibility of something entirely new. It is humbling to consider how fragile this balance has always been. A few degrees hotter, and the oceans might never have condensed. A weaker magnetic field, and the atmosphere might have vanished into space. A slightly different mix of gases, and the planet might have remained sterile forever. And yet, Earth managed to carve out the perfect balance: oceans deep enough to nurture chemistry, air thick enough to shelter it, but not so thick as to smother it. This balance remains today, though we test it constantly with our own actions, burning fuels and changing the very chemistry of the air. But in those early ages, it was not humanity that threatened balance. It was nature itself, violent and unpredictable, yet ultimately creative. As Earth's oceans and atmosphere stabilized, they transformed not just the planet, but the very definition of what was possible. Oceans carved coastlines, absorbed gases, and began cycles that still exist today: the endless evaporation of water into clouds, the falling of rain, the erosion of rock into rivers, and the return of minerals back to the sea. The atmosphere grew thick enough to scatter blue light, turning the sky a color that life would one day see and marvel at. From poison and storm, beauty emerged. From chaos and fire, calm took hold. And from that calm, the stage was set for the greatest drama of all: the spark of life. This chapter of Earth's story reminds us of something essential. What we call stability is always built on instability. What we call home was once uninhabitable. The seas we swim in and the air we breathe were once toxic and violent. Every comfort we know is the result of billions of years of trial, error, destruction, and chance. The oceans and atmosphere were not gifts. They were victories, hard won in the crucible of a young planet's fury. And it is only because of them that we are here, able to tell the story at all. When Earth's oceans finally formed and the skies calmed just enough to hold water, a new chapter began, one that would change the planet forever. Because out of the chaos of volcanic fire, acid seas, and storm-choked skies, something extraordinary happened. The first spark of life appeared. It's almost impossible to overstate the mystery of this moment. How does something as complex and fragile as life emerge from lifeless chemistry? Even today, scientists cannot pinpoint exactly when or how it happened. What we do know is that somewhere between 3.5 and 4 billion years ago, the first living systems began to stir in Earth's oceans, and once they appeared, they refused to vanish. Life became Earth's greatest experiment, and its most dangerous force of change. The conditions of early Earth were anything but gentle. The seas were thick with dissolved minerals, hot near volcanic vents, bombarded by ultraviolet radiation from the sun, and constantly stirred by lightning storms above. Yet it was within this harsh environment that simple molecules came together in complex ways. Scientists believe that hydrothermal vents, cracks in the ocean floor spewing superheated, mineral-rich water, may have provided the perfect cradle. These vents created pockets of energy and chemistry, where carbon-based molecules could link together, forming the first chains of RNA or protein. Picture a dark, alien seafloor where chimneys of black smoke rise into the water, and within those chimneys, bubbles form with tiny walls that shelter fragile molecules. In those bubbles, chemistry becomes biology. It is in these places that non-living matter may have crossed the threshold into life. The earliest forms of life were not plants or animals, but microscopic organisms. They were single-celled, tiny beyond imagination, yet powerful in their resilience. They consumed simple molecules for energy, multiplied, and passed on information to their offspring. These first cells may have been fragile individually, but in numbers, they were unstoppable. They colonized the oceans, clinging to rocks, floating in the water, and multiplying wherever conditions allowed. From the moment they appeared, life became a permanent feature of Earth. No matter how many extinctions would follow, no matter how violent Earth's future would become, life never let go of its foothold again. But the story of life's early days is not just about survival, it's about transformation. One of the most shocking events in Earth's history came not from asteroids or volcanoes, but from life itself. Around 2.4 billion years ago, tiny microbes known as cyanobacteria discovered how to harness sunlight. Through photosynthesis, they converted carbon dioxide and water into energy, releasing oxygen as a waste product. To us, oxygen is essential, but to the organisms of that time, oxygen was poison. The release of oxygen into the atmosphere caused what scientists call the Great Oxygenation Event, and it was nothing less than catastrophic. The air filled with a reactive gas that killed off vast numbers of anaerobic organisms, triggering one of the first mass extinctions in Earth's history. Life had begun to shape the planet in ways no volcano or asteroid ever could. The Great Oxygenation Event also marked the beginning of Earth's skies as we know them. For the first time, oxygen accumulated in the atmosphere, eventually forming an ozone layer that blocked deadly ultraviolet radiation. This new protective shield allowed life to expand and evolve in new directions. Oxygen also enabled the rise of more complex cellular machinery, leading to the development of eukaryotes, cells with nuclei and organelles. These organisms, larger and more sophisticated than bacteria, were the ancestors of all plants, fungi, and animals. It's humbling to realize that everything from forests to humans traces its lineage back to this turning point, when tiny microbes filled the world with oxygen and paved the way for complexity. Yet life's path was never easy. Earth plunged into at least 2 Snowball Earth episodes, where the entire planet froze from pole to pole. For millions of years, the oceans were sealed beneath ice, and sunlight barely reached the water below. Life could have ended in those times, smothered by cold and isolation. And yet in deep-sea vents and tiny cracks in the ice, microbes endured. They found ways to adapt, to hide, to persist against odds that should have annihilated them. Each time Earth pushed life to the brink, life found a way back, more resilient than before. The emergence of multicellular life was another leap in this long experiment. Around 600 million years ago, cells began cooperating, forming colonies that acted as single organisms. This cooperation led to specialization, where some cells focused on movement, others on feeding, and others on reproduction. With this came the explosion of forms that would later dominate the Cambrian period, creatures with shells, spines, eyes, and jaws. But it all began with that first step, simple cells deciding not to go it alone, but to work together. Cooperation, not just survival, became life's greatest weapon. What is striking in this story is how life did not just adapt to Earth, it altered Earth itself. Microbes reshaped the atmosphere, changing its composition forever. Organisms altered the chemistry of oceans, depositing layers of minerals that became limestone and chalk. Plants, once they evolved, transformed continents by stabilizing soils and pumping oxygen into the skies. Every stage of life's evolution left fingerprints on the planet. Today, when scientists dig into rocks billions of years old, they find those fingerprints tiny fossils of bacteria, layers of iron rusted by oxygen, and chemical signatures that whisper of ancient metabolisms. Life is not just a guest on Earth, it is a force that has sculpted the very face of the planet. Perhaps the most mysterious part of this chapter is the leap from non-life to life itself. Even with all our science, we still don't fully understand how inert molecules became self-replicating systems capable of evolution. Was it sparks of lightning striking chemical soups, as the famous Miller-Urey experiment suggested? Was it deep-sea vents rich in minerals and heat? Was it even possible that life's building blocks came from elsewhere, carried on meteorites that crashed into Earth? The answers remain elusive. What is certain is that once life appeared, it proved unstoppable. In a universe that seems vast and indifferent, Earth became a world alive, and it has never returned to lifelessness. The lesson of this period is both humbling and haunting. Life did not begin in comfort. It began in extremes. It did not need perfect skies or peaceful seas. It began in poison, in fire, in storm, in ice, and it endured through cataclysms that could have erased it countless times. If life could survive that, it is no wonder it has endured every extinction since. But it also reminds us that life is fragile in its forms, even if it is resilient in its persistence. Whole lineages vanished when oxygen filled the air. Whole ecosystems collapsed during global freezes. And yet the thread of life continued, thin but unbroken. By the time complex life finally began to flourish, Earth had already been alive for billions of years. The foundations of everything we know, oxygen in the skies, stable oceans, protective ozone, were built by the work of microbes unseen but monumental. It is strange to think that the greatest architects of Earth's habitability were not towering trees or mighty animals, but microscopic beings too small to see with the naked eye. And yet, without them, there would be no forests, no animals, no humans. Life's first spark was humble, but its consequences were vast. This stage of Earth's story teaches us something unsettling. Life does not simply adapt to Earth, it transforms it. It always has, and it always will. And as we move into the age of humanity, we must confront a troubling thought: if microbes could alter the planet on a global scale billions of years ago, what does it mean when a species with machines, technology, and billions of people now takes the stage? The precedent is clear. Life changes Earth, and now we are the life doing the changing. When people look at a world map, they often imagine that continents have always been fixed, like puzzle pieces locked in place since the beginning. But nothing about Earth is permanent, not even the land beneath our feet. The surface of our planet is not a solid, unchanging shell, but a restless skin, broken into massive slabs called tectonic plates that drift, collide, and tear apart over time. These movements are slow, measured in centimeters each year, but across millions of years they have rearranged the entire face of Earth again and again. Continents that now lie oceans apart were once pressed together as one. Mountains that tower above us today will one day erode into plains. Seas that seem eternal will vanish, replaced by deserts or new oceans. The story of Earth's shifting crust is one of destruction and rebirth, of continents merging into giants and breaking apart in cycles that span hundreds of millions of years. And within these cycles lies the hidden history of life itself. For every collision, every rift, every new ocean shaped the path of evolution. The most famous of these ancient landmasses is Pangaea, the supercontinent that existed about 345 million years ago. Pangaea was enormous, a single continent that stretched from pole to pole, containing almost all the land on Earth. Imagine looking at a globe then. No Atlantic Ocean, no scattered continents, just one massive expanse of land, surrounded by a single world ocean called Panthalassa. To live in Pangaea's time would have been to stand in the middle of vast interiors far from any coast, where climates were extreme and deserts stretched for thousands of miles. But Pangaea was not the first of its kind. It was only the latest in a long series of supercontinents, following earlier giants like Rodinia and Columbia, each one forming and breaking apart in a cycle scientists call the supercontinent cycle. The continents are like restless travelers, sometimes gathering together for eons, only to drift apart again, reshaping the globe endlessly. This restless motion is powered by heat, deep within Earth. The planet's core, still seething with the energy left from its violent birth and the decay of radioactive elements, drives convection currents in the mantle, the thick layer of rock beneath the crust. These currents push and pull the plates above, forcing them to move. When plates collide, mountains rise. When they separate, oceans are born. When one plate slides beneath another in a process called subduction, volcanoes erupt and new crust forms. The continents we walk upon are not static ground. They are rafts floating on a restless sea of molten rock. Every earthquake, every volcanic eruption is a reminder of that hidden power beneath. The breakup of Pangaea beginning about 17.5 million years ago reshaped the Earth into something closer to what we recognize today. As the great landmass cracked apart, rifts opened that eventually became the Atlantic Ocean. Continents drifted into new positions, South America pulling away from Africa, India racing northward toward Asia, and Australia splitting from Antarctica. These movements didn't just change geography, they rewrote climates and ecosystems. As continents drifted, ocean currents shifted, winds changed, and species adapted or vanished. The breakup of Pangaea, for example, created isolated regions where species evolved independently, leading to the staggering diversity of life we see across the globe today. The creatures of South America, Africa, and Australia developed in isolation for millions of years, producing unique animals found nowhere else. Without plate tectonics, there would be no kangaroos, no sloths, no lemurs. Mountains are another testament to Earth's restless skin. The Himalayas, the tallest mountains on Earth, exist because India collided with Asia after breaking away from Gondwana, a southern fragment of Pangaea. That collision, which began about 50 million years ago, is still happening today, forcing the Himalayas higher each year. The Alps, the Rockies, the Andes, all were born from collisions of continents. Every mountain range is a scar, a record of violent encounters between plates, and when mountains rise, they reshape weather, carve rivers, and influence life. The uplift of the Himalayas, for instance, altered Asian climates, creating monsoons and shaping ecosystems from India to China. But it's not only the continents that tell this story. Oceans themselves are born and destroyed by the same restless forces. The Atlantic Ocean, young compared to other seas, continues to widen today as the mid-Atlantic ridge pushes its floor apart. Meanwhile, the Pacific Ocean shrinks as its crust is consumed by subduction zones around its edges. One day, far into the future, the Pacific may disappear entirely, replaced by new continents merging again. Earth is always in motion, always erasing and creating, a planet whose map is never final. For life, these changes were both opportunities and catastrophes. When continents merged into supercontinents, coastlines shrank, reducing shallow seas where marine life thrived. Vast interiors became deserts, challenging plants and animals to adapt. When continents split apart, coastlines expanded, creating new habitats and driving bursts of evolution. Isolation sparked diversity, while collisions drove extinctions. The very ground beneath us has dictated the rise and fall of species for billions of years. Dinosaurs themselves owed their dominance partly to the breakup of Pangaea, which opened new ecological niches and set the stage for their expansion. Later, when continents shifted again, their reign ended, paving the way for mammals. Even human history has been shaped by this restless earth. The fertility of river valleys like the Nile, the Indus, and the Yellow River comes from soils enriched by tectonic activity. The metals that fueled the Bronze and Iron Ages were forged in the heat of subduction zones and brought to the surface by volcanism. The mountains and seas that define cultures and nations exist because of plate movements that began millions of years before humanity appeared. Without Earth's shifting skin, there would be no continents to inhabit, no resources to mine, no barriers or connections to shape civilizations. Our history is inseparable from Earth's geology. What makes this story even more astonishing is how much of it is hidden. Most of Earth's early crust has been recycled back into the mantle through subduction, erased forever. We piece together the puzzle of ancient supercontinents from scattered clues, rocks that match across continents now separated by oceans, mountain chains that continue from one landmass to another, fossils of identical species found on opposite sides of the globe. These fragments are whispers of a deep past, reminders that the land beneath us has been everywhere else before. The restless skin of Earth is also a warning. The same forces that built continents and mountains can bring devastation in an instant. Earthquakes level cities, tsunamis swallow coastlines, volcanoes bury landscapes in ash. These disasters remind us that the ground we see as stable is anything but. We live on a dynamic planet, one that shifts and groans beneath our feet, indifferent to our presence. Yet it is that very dynamism that makes Earth habitable. Without plate tectonics, carbon would not cycle between the atmosphere and the crust. Without mountains, rainfall patterns would collapse. Without ocean ridges and subduction, nutrients would not circulate to sustain life. Earth's restlessness is not just danger, it is life itself. When you walk across a continent, you are walking across history older than humanity, older than most life. The rock beneath your feet may have once been at the bottom of an ocean, crushed in a mountain, or drifting across the equator. Continents have wandered the globe like nomads, colliding, breaking, reforming, and leaving trails of life in their wake. What seems permanent is only temporary. The continents of today are just the latest arrangement in a cycle that will continue long after we are gone. One day, far into the future, a new supercontinent will form, reshaping oceans, climates, and life itself. Earth will keep moving, with or without us. The story of Earth's restless skin is a reminder that our planet is not a static stage on which history plays out. It is an actor itself, always shifting, always changing the script. And while we often see mountains, oceans, and continents as backdrops to our lives, they are in fact the main characters of a drama billions of years old. To understand this is to see Earth not as stable ground, but as a living, moving force. And to live here is to live on a world that never stops rewriting itself, a world whose map is always temporary, a world in motion. If there is one pattern that defines Earth's history of life, it is this. Nothing survives forever. Species rise, spread, and dominate. But eventually they are tested by the planet itself. And sometimes those tests come in the form of cataclysmic events, so devastating that they wipe out not just individual lineages, but entire ecosystems. entire worlds of living things. These are the mass extinctions, the ultimate reset buttons in Earth's story. Over the last 500 million years, life has been forced to endure at least 5 major ones, each reshaping the planet's cast of characters, each clearing the stage for something new to take its place. And what's most shocking is not just that these extinctions happened, but that they reveal a truth about survival. Being the strongest doesn't guarantee safety. Being the most dominant doesn't secure the future. When Earth decides to press reset, even the mightiest can vanish overnight. The first of these great extinctions came about 4.5 million years ago during the Ordovician period. At that time, Earth was a planet dominated by oceans. Complex life had just begun to spread across the seas, filling them with trilobites, brachiopods, and the first reef systems. But then, something extraordinary happened. A massive glaciation swept across the planet, triggered by shifting continents and changes in carbon dioxide levels. Ice sheets spread across Gondwana, locking up huge amounts of water and causing sea levels to plummet. Shallow seas that had been teeming with life drained away, leaving countless organisms stranded. Nearly 85% of marine species were wiped out. It was a brutal reminder that life's stability depends on a delicate balance of climate and oceans, a balance that can be broken by Earth's own rhythms. And yet, in the aftermath, survivors adapted, and new ecosystems emerged from the ruins. The second great extinction came during the Devonian, about 3.75 million years ago, a time when fish dominated the seas and the first plants had begun to colonize land. This extinction unfolded not in one sudden blow, but in waves across millions of years. Coral reefs collapsed, ocean chemistry shifted, and oxygen levels plummeted in vast regions of water, creating deadly dead zones. The causes remain debated, perhaps massive volcanic eruptions, perhaps the spread of land plants altering carbon cycles, or perhaps asteroid impacts. Whatever the cause, the effect was catastrophic. Up to 75% of all species vanished, including many early fish lineages. But the extinction also cleared the way for new survivors. Out of the rubble, creatures that would one day give rise to amphibians and land vertebrates pushed forward, their dominance secured by the removal of competitors. Then came the third and most devastating extinction of all, the Permian-Triassic extinction, often called the Great Dying. This event, about 25.2 million years ago, almost ended life itself. It was triggered by massive volcanic activity in Siberia, eruptions so vast they poured out lava across an area larger than modern Europe. These eruptions released colossal amounts of carbon dioxide and methane, triggering runaway climate change. Oceans warmed, acidified, and became deprived of oxygen. Land suffered under extreme heat and toxic air. Nearly 96% of marine species and 70% of terrestrial vertebrates disappeared. Entire groups, like trilobites that had survived for hundreds of millions of years, vanished forever. For a moment, Earth seemed almost sterile, and yet somehow, life clung on. A handful of survivors, ancestors of reptiles, amphibians, and plants, endured the chaos. It is from these survivors that the age of the dinosaurs would eventually rise. The Great Dying is a haunting reminder of how fragile existence can be, how close Earth came to losing its story entirely. The fourth great extinction occurred about 20 million years ago at the end of the Triassic period. By then, dinosaurs had begun their rise, but they were far from dominant. The Earth was splitting apart, as Pangaea cracked and new oceans formed. This period of tectonic upheaval unleashed colossal volcanic eruptions along the Central Atlantic magmatic province, flooding the air with greenhouse gases. The result was rapid climate swings, ocean acidification, and mass extinctions. Roughly 80% of species vanished, including many large amphibians and early reptiles. But from this devastation, dinosaurs emerged as the clear winners. With their rivals gone, they spread across the globe, seizing dominance for the next. Without the Triassic extinction, the age of dinosaurs might never have come. The fifth and most famous extinction is the Cretaceous-Paleogene event, 66 million years ago, the day the dinosaurs' reign ended in fire and darkness. It began with a rock from space, an asteroid 6 miles wide, that slammed into what is now the Yucatan Peninsula. The impact released energy greater than 1 billion nuclear bombs, vaporizing rock, igniting forests and hurling debris into the atmosphere. Darkness cloaked the planet as sunlight was blocked for months, maybe years. Temperatures plummeted, photosynthesis collapsed, and ecosystems unraveled. Dinosaurs, except for the ancestors of modern birds, were wiped out. So too were countless marine reptiles, ammonites and other groups. Yet from this apocalypse, mammals rose. Small, adaptable creatures that had lived in the shadows of giants now inherited the earth, setting the stage for the eventual rise of humans. What these 5 great extinctions show us is that Earth has a reset button, and it presses it often enough to redefine life. The planet does not favor any one form of dominance. Trilobites ruled for millions of years, then vanished. Dinosaurs reigned for over 100 million years, then disappeared in a geological instant. The key to survival has never been strength or size, but adaptability. Those that could endure radical change, creatures small, flexible, or lucky, are the ones who carried life forward. Every extinction destroyed worlds, but each also created opportunities. Without them, mammals might never have risen. Without them, we would not be here. But here's the chilling part. Scientists argue that we are now living through a 6th extinction, one not caused by asteroids or volcanoes, but by ourselves. Human activity, from deforestation to climate change to overhunting, is driving species to extinction at rates not seen since the last great die-off. Amphibians, insects, birds, and mammals are vanishing faster than they can be replaced. The same forces that wiped out past worlds, climate shifts, loss of habitat, chemical imbalances, are now being unleashed by humanity. We are no longer just passengers on Earth's journey, we have become a geological force in our own right. The story of mass extinctions is more than history, it's a warning. Earth does not promise stability. Life exists on borrowed time, always one catastrophe away from being reshaped. And when the reset button is pressed, there are no guarantees. What survives is what can adapt, what can endure, what can bend without breaking. Every extinction has proven this. And now, as we drive changes faster than ever before, we are forcing life, including ourselves, into another test. Yet, if there is hope, it lies in the resilience life has always shown. From the edge of nothingness after the Great Dying, life returned, diverse and thriving. From the shadow of the asteroid, mammals rose. Every extinction clears the board, but the game continues. Life finds a way forward, and perhaps that is the deepest lesson. Extinction is not the end of life on Earth, but the end of one version of it. Another always follows. The question now is, what version comes next, and will we be part of it? When the dust of the Triassic extinction settled and the Earth began to breathe again, a new era dawned. The survivors of that catastrophe stepped into a changed world, and among them, one group was poised to dominate like no creatures before, the dinosaurs. For over 35 million years, they ruled the Earth, evolving into creatures that stretched imagination to its limits. Colossal giants that shook the ground, predators with teeth like knives, and flyers that turned the skies into their hunting grounds. It was an age unlike any other, one defined by the sheer scale and diversity of life. An era when reptiles shaped every ecosystem from steaming jungles to barren deserts. To understand the age of dinosaurs is to understand how power, size, and adaptation can carve out supremacy on a planet that never stops changing. The dinosaurs first appeared in the late Triassic, around 230 million years ago. At first, they were not the fearsome giants we imagine today, but small, agile creatures competing with other reptiles and mammal-like animals. They weren't immediately dominant, but they had a secret weapon: adaptability. Their bodies allowed them to move efficiently, conserve water, and grow into diverse forms suited to different environments. As the Triassic extinction cleared away competitors, dinosaurs expanded into every available niche. By the Jurassic, they were everywhere, filling the seas, skies, and land with forms that seemed designed to test the limits of life itself. What made dinosaurs so successful wasn't just their size, it was their diversity. Some evolved into towering sauropods, the largest animals ever to walk the land. Imagine forests where creatures like Brachiosaurus raised necks higher than 5-story buildings, stripping leaves from trees that no other herbivore could reach. Others became armored tanks, like Ankylosaurus, covered in bony plates and wielding tail clubs strong enough to shatter bones. Predators grew into relentless hunters, like Allosaurus in the Jurassic and later the infamous Tyrannosaurus rex in the Cretaceous. Animals that embodied raw power and efficiency. But dinosaurs also produced swift runners, small scavengers, and even early flyers. The skies of the Mesozoic were ruled by pterosaurs, their wingspans stretching longer than buses. The age of dinosaurs was not just an age of giants, it was an age of experimentation, with evolution exploring every possibility. The world itself during this time was vastly different. The Jurassic period saw lush, humid forests where conifers and cycads dominated, providing endless food for herbivores. The Cretaceous brought flowering plants, a revolution in ecosystems that reshaped diets and relationships between species. With new plants came pollinators, insects that evolved alongside them, and soon entire webs of life depended on this dynamic. Dinosaurs thrived in these changing environments, adapting to the new food sources and shaping the landscapes themselves. Herds of sauropods could transform forests into open plains, while predators followed their movements, creating a balance of power and survival that lasted for millions of years. One of the most fascinating aspects of dinosaurs is how they challenged our understanding of what it means to be alive. For centuries, they were imagined as sluggish reptiles, cold-blooded and lumbering. But modern discoveries reveal a very different truth. Many dinosaurs were warm-blooded or had bird-like metabolisms that allowed for constant activity. Fossil evidence shows feathers on numerous species, not just small ones but even on some of the larger predators. These feathers may have begun as insulation, but later evolved into tools for display, camouflage and flight. The link between dinosaurs and birds is undeniable. Every bird alive today is a living dinosaur, a direct descendant of that ancient lineage. When we watch a hawk dive from the sky or a sparrow flit across a street, we are witnessing the legacy of the age of giants in miniature form. The dominance of dinosaurs was not unchallenged. Throughout their reign, the planet continued to test them with climate shifts, volcanic eruptions and changing seas. Yet, time and again they endured. Their adaptability allowed them to diversify into over 1,000 species that we know of today, with countless more lost to time. Some thrived in polar regions where long winters forced resilience, while others conquered deserts where survival meant efficiency in heat. From apex predators to gentle giants, from armored herbivores to swift hunters, dinosaurs were not just rulers of their age, they were survivors across extremes. And yet, for all their resilience, they were not eternal. 66 million years ago, at the height of their diversity, their world ended in an instant. The asteroid impact that struck near the Yucatan Peninsula ended their reign with brutal efficiency. Forests burned, sunlight vanished, and food chains collapsed. Dinosaurs that had roamed for over 100 million years were gone almost overnight, their dominance shattered. But this ending only highlights how extraordinary their age was. For all of human history we have lived in their shadow, digging their bones from the earth, marveling at the creatures that once shaped the world. No mammal, no primate, not even humans have yet matched the sheer duration of their dominance. What remains most striking about the dinosaurs is how they remind us of life's possibilities. They stretched size to its maximum, proving that Earth could sustain creatures weighing over 70 tons. They experimented with form, from the spiked crests of hadrosaurs to the deadly claws of raptors. They bridged the gap between reptile and bird, showing how life can leap into entirely new forms. Even in death, they shaped the earth. Their bones became stone, their bodies fed ecosystems, and their extinction paved the way for mammals and eventually humans to rise. In every sense, they are part of our story. To walk through a world filled with dinosaurs would have been to live in a constant state of awe and fear. Imagine a plain where sauropods marched like moving hills, their steps shaking the ground. Picture a forest where raptors hunted in packs, their intelligence as dangerous as their claws. Visualize a coastline where flying reptiles with wingspans wider than jet planes soared above the waves, diving for fish. It was a world of extremes, a theatre of life more dramatic than anything we can see today. And though it ended in fire and shadow, its echoes remain in the birds that fill our skies and the fossils we dig from stone. The reign of the dinosaurs tells us something profound, that dominance is temporary, but influence can be eternal. They ruled for longer than humans can imagine, but even when their age ended, they left behind a blueprint of survival, adaptation, and change. Their extinction was not just a loss, it was a handoff, a passing of the torch to mammals, and eventually to us. But perhaps the deeper lesson is this: if creatures as mighty as dinosaurs could fall, then no dominance is safe forever. The Earth always tests its inhabitants, always reminds them that survival is about more than power. It is about resilience, adaptability, and the ability to endure change. The Age of Dinosaurs was a chapter in Earth's story that showcased life at its grandest, most daring, and most spectacular. It proved what evolution could create when given time and opportunity, and though their age ended, their shadow remains, a reminder that life can rise to unimaginable heights and fall just as quickly. When the Age of the Dinosaurs ended in fire and darkness, it was easy to imagine that life itself had been shattered beyond repair. For over 100 million years, dinosaurs had ruled every corner of Earth, filling the skies, the oceans, and the land with a staggering diversity of forms. But when the asteroid struck and ecosystems collapsed, their dominance ended in a geological instant. For many creatures, there was no tomorrow, yet, in the ashes of that cataclysm, life once again proved its greatest strength. Resilience. Among the survivors were small, unassuming mammals, creatures that had spent the Mesozoic era living in the shadows, hiding from the giants that towered over them. These survivors, no larger than rodents in most cases, were quick, adaptable, and able to exploit niches left vacant by the disappearance of the dinosaurs. And from these humble beginnings, mammals rose to become the new masters of Earth. Before the asteroid, mammals had been confined to the margins. They were mostly small nocturnal insect eaters, living secret lives while dinosaurs dominated daylight. Their size and habits were not disadvantages, however, they were precisely what allowed them to endure the disaster. When forests burned and climates plunged into chaos, smaller animals that could burrow, eat, varied diets, and reproduce quickly had better odds of survival. The colossal dinosaurs could not adapt to such sudden scarcity, but mammals could. Their ability to regulate body temperature, feed on insects, seeds and roots, and hide in burrows allowed them to weather the storm. When the dust began to clear and ecosystems slowly recovered, mammals were poised to take advantage of the new world. The Paleogene period, which followed the extinction event, was the true beginning of the mammalian age. Freed from the shadow of dinosaurs, mammals underwent an extraordinary burst of evolution, spreading into every environment and experimenting with forms as diverse as the ecosystems they entered. In a relatively short time, they grew larger, more specialized, and more dominant. Some became herbivores that filled the roles once held by giant dinosaurs, grazing across new grasslands and forests. Others became predators, evolving sharp teeth, speed, and cunning to chase their prey. Mammals filled the seas, producing early ancestors of whales and dolphins. They took to the air, with bats developing wings and echolocation to hunt in darkness. And on land they produced a dazzling array of forms from tiny shrews to massive mammoths. The age of mammals was not one of subtlety but of reinvention, a new era where every possibility was tested. The rise of mammals also reshaped the Earth itself. With the appearance of grasses around 40 million years ago, landscapes changed dramatically. Grasslands spread across continents, creating vast open spaces that supported herds of grazing animals. These herds in turn shaped the predators that hunted them, driving the evolution of speed and endurance. Horses, antelopes, and bison ran across plains, while lions, cheetahs, and wolves evolved to chase them. The predator-prey arms race became one of the defining features of the Cenozoic era, a cycle of adaptation that fueled evolution at a rapid pace. Mammals were no longer just survivors, they were sculptors of ecosystems, driving the dynamics of life in ways unseen since the dominance of dinosaurs. One of the most astonishing stories of the mammalian age is the rise of whales. These giants of the sea began as small, land-dwelling mammals that waded into shallow waters to hunt. Over millions of years, their bodies transformed, losing hind limbs, elongating spines, and developing tails and flippers. Their nostrils shifted to the top of their heads to form blowholes. Teeth in some lineages gave way to baleen plates that filtered plankton. Today's whales, from the colossal blue whale to the agile orca, are living proof of evolution's power to reshape life into entirely new forms. It is remarkable to think that the largest animal in Earth's history is not a dinosaur but a mammal, and it swims in our oceans today. But the story of mammals is not only about size or dominance, it is also about intelligence. Mammals developed larger brains relative to body size, which allowed for more complex behaviors, social structures, and problem-solving skills. Primates in particular evolved with forward-facing eyes, grasping hands, and advanced cognition, traits that would eventually set the stage for humanity. The social lives of mammals, from elephant herds, wolf packs, reflected not just survival strategies, but emotional bonds and communication that hinted at deeper awareness. The age of mammals was also the age of rising intelligence, a slow march toward the possibility of consciousness as we know it. Climate shifts during this time tested mammals again and again, but each shift brought new opportunities. When ice ages spread across the planet, mammals adapted by growing thick coats, migrating or hibernating. Mammoths and saber-toothed cats thrived in icy landscapes, while other species dominated warmer refuges. Extinctions continued, as they always have, but mammals proved remarkably resilient, diversifying in the face of every change. This adaptability is why they rose where dinosaurs fell. It wasn't just luck that saved them after the asteroid. It was flexibility written into their very biology. And then, within the story of mammals came a twist that would change Earth forever: the rise of humans. From small primates climbing in trees came lineages that walked upright, used tools, and began to shape the world around them. Millions of years, mammals had been shaped by Earth, by climate, by catastrophes and opportunities. But with humanity, the cycle reversed. Now, for the first time, one species of mammal began shaping the Earth itself on a scale previously reserved for tectonics and asteroids. This shift marks the most dramatic turn in the story of life, one still unfolding today. What makes the mammalian rise so compelling is how quickly it happened in geological terms. In just 66 million years, a blink compared to the hundreds of millions of years dinosaurs ruled, mammals went from scurrying survivors to architects of global ecosystems. Their story proves that dominance is not measured by time alone, but by impact. Dinosaurs lasted longer, but mammals reshaped the world in new and profound ways. From carving out grasslands to re-engineering oceans, from producing whales to producing humans. Their adaptability became not just a survival trait, but a weapon that allowed them to thrive in every corner of the planet. And yet, the same truth that applied to dinosaurs still applies to mammals. Nothing lasts forever. The dominance of mammals is just another chapter in Earth's long history of change. One day, the Earth will again test life with catastrophes of unimaginable scale, and when that day comes, survival will depend on adaptability, just as it always has. Whether mammals endure that test remains uncertain. But what is certain is that the story of mammals, our story, is one of resilience, reinvention and dominance carved from the ashes of catastrophe. The age of mammals is still ongoing, but already it has reshaped Earth in ways that rival any supercontinent or asteroid. It began with tiny survivors hiding in the dark, and it has led to species that can split the atom, reach the stars, and tell the story of the planet itself. That is the power of survival, the legacy of resilience, and the proof that even in the shadow of giants, the smallest creatures can one day rise to rule the world. The age of mammals unfolded with astonishing speed, but it was the ice ages that carved its most dramatic chapters. Beginning about 2.5 million years ago, Earth entered the Quaternary period, a time defined by cycles of glaciation and warming that reshaped continents, oceans, and life itself. Vast ice sheets spread from the poles, advancing and retreating like tides, grinding mountains into valleys, and carving lakes that would one day nourish civilizations. These icy pulses tested every creature, forcing adaptations and extinctions, but they also set the stage for the rise of giants, the megafauna, and eventually the emergence of humans, who would not just endure these challenges, but bend the planet to their will. The Ice Ages were not just a time of hardship, they were the crucible that forged our ancestors. During glacial peaks, ice sheets stretched over much of North America, Europe, and Asia, burying landscapes under kilometers of frozen mass. Sea levels dropped by more than 100 meters, exposing land bridges that connected continents and allowed animals, and eventually humans, to migrate across the globe. When the ice retreated during warmer interglacials, grasslands expanded, forests spread, and new habitats opened. These cycles of advance and retreat created constant upheaval, demanding flexibility from every species. Those that could not adapt vanished. Those that could evolved into some of the most impressive creatures Earth has ever seen. This was the era of the megafauna, the great mammals that stalked and grazed across icy plains and tundras. Imagine herds of woolly mammoths, towering creatures with tusks that curved like scythes, covered in thick coats to withstand the cold. Picture saber-toothed cats, their elongated fangs built for piercing the hides of massive prey. Envision giant ground sloths as tall as trees, lumbering through forests to pull down branches, or mastodons, cousins of elephants, roaming in vast numbers across continents. Even rodents and birds grew large in this age, with beavers the size of bears and flightless birds towering over humans. These were animals shaped for extremes, perfectly adapted to a world of ice and grass. Yet the Ice Ages were not only about beasts, they were about survival strategies that redefined what it meant to live. Some species developed thick fur, others immense fat reserves, while still others learned to migrate long distances in search of food. Wolves formed cooperative packs, their bonds allowing them to hunt prey much larger than themselves. Caribou and bison learned to travel in massive herds, overwhelming predators with sheer numbers. Life was a battle between predator and prey, survival and starvation, adaptation and extinction. Every creature existed on a knife's edge, where a slight shift in climate could mean the difference between prosperity and annihilation. It was in this unforgiving landscape that humans emerged. Our ancestors, Homo habilis and Homo erectus, had already learned the rudiments of tool use and fire, but it was during the Ice Ages that human evolution accelerated. The challenges of cold climates demanded clothing, shelter, and cooperation. Hunting massive animals required strategy, communication, and weaponry beyond mere stone flakes. Fire became not just a tool but a lifeline, warding off predators and extending human activity into frozen nights. In the crucible of ice, humans honed intelligence, creativity, and resilience, traits that would eventually elevate them above all other creatures. The Ice Ages also shaped human migration. Lower sea levels exposed land bridges such as Beringia, which connected Siberia to North America. These frozen pathways allowed humans to spread across continents, reaching Europe, Asia, Australia, and eventually the Americas. Each migration brought humans into contact with new ecosystems, new challenges, and new opportunities. Wherever they went, they adapted, crafting tools from local resources, inventing clothing from animal skins, building shelters from wood, bone, and stone. Unlike most animals, which were tied to specific habitats, humans became generalists, able to survive in deserts, forests, tundras, and mountains alike. This flexibility was their ultimate advantage. But humans were not mere participants in Ice Age ecosystems, they were disruptors. Armed with intelligence and cooperation, they became super predators, capable of hunting animals far larger than themselves. Evidence suggests that human hunting, combined with climate shifts, played a major role in the extinction of many megafauna species. Mammoths, mastodons, saber-toothed cats, giant sloths, and countless others vanished during the late Ice Age, leaving behind bones and legends. In a sense, humans became the asteroid of the Quaternary, altering ecosystems not by cosmic impact but by persistence, fire, and spear. These extinctions were the first hints of a pattern that would define human history. Wherever humans went, landscapes and species would change forever. Yet, even as humans contributed to extinctions, the Ice Ages gave them gifts. The shifting climates created fertile valleys when ice receded, carving rivers and lakes that later became cradles of civilization. Glacial deposits enriched soils, enabling agriculture long after the ice had melted. Rivers fed by glacial melt provided water routes for trade and survival. The very geography of modern continents, the Great Lakes, the fjords of Scandinavia, the rolling plains of North America was sculpted by glaciers. Humans inherited not just the challenges of the Ice Ages but the landscapes they left behind. By the end of the last Ice Age, about 11,700 years ago, the stage was set for humanity's next transformation. The warming climate stabilized, glaciers retreated, and sea levels rose, flooding the land bridges that once connected continents. As grasslands gave way to forests and fertile river valleys, humans began experimenting with farming, domesticating plants and animals, and settling into permanent villages. This was the dawn of civilization, and it was only possible because the Ice Ages had forced humanity to adapt, innovate, and spread across the globe. Without the trials of ice and scarcity, humans might never have developed the resilience and ingenuity that allowed them to dominate the Holocene. The Ice Ages are often imagined as bleak and lifeless, but in truth they were periods of extraordinary dynamism. They tested life in ways few other eras had, forcing species to grow, shrink, migrate, or perish. They created giants, sculpted landscapes, and gave rise to a species capable of surviving not just by adapting to nature, but by reshaping it. They remind us that struggle is often the parent of innovation, that cold and scarcity can forge strength and creativity. Without the Ice Ages, there would be no humans, no civilizations, no history as we know it. And yet, their lessons are sobering. The Ice Ages show us how fragile ecosystems can be when faced with rapid climate shifts. Just as mammoths and saber-toothed cats vanished when ice receded and humans hunted, countless species today face similar fates under the pressures of modern climate change and human expansion. The story of the Ice Ages is not just about survival in the past. It is a mirror of the challenges we face now. To look back on the Ice Ages is to see a planet that tested every form of life, often to the brink of extinction. It is to see megafauna that inspire awe even in their absence, landscapes sculpted by rivers of ice, and humans rising from obscurity to prominence. It was an age where giants walked, where predators wielded teeth like sabers, where ice carved mountains and valleys, and where one species of primate learned to not just endure but to thrive. From the Ice Ages, humanity inherited a world remade, and the tools to claim it. But along with those tools came responsibility, the power to alter ecosystems, to drive species to extinction, and to shape the climate itself. The Ice Ages gave us our chance. What we do with it is the next chapter in Earth's story. When the last Ice Age ended about 11,700 years ago, the planet entered the Holocene epoch, a period of warming and relative climate stability. The glaciers retreated, rivers swelled, and fertile soils were left behind by melting ice. For humanity, this shift was nothing short of revolutionary. For hundreds of thousands of years, humans had survived as nomads, moving in small bands across landscapes, hunting animals and gathering plants. Their lives were dictated by seasons, migrations, and chance. But as the Earth's climate stabilized, something unprecedented began. Humans discovered that they could not only harvest food from nature, but shape nature itself to produce food. This was the agricultural revolution, a transformation so profound that it turned humans from wanderers into settlers, from survivors into builders of civilization. The first seeds of agriculture sprouted in the Fertile Crescent, a region stretching through modern-day Iraq, Syria, and Turkey. Here wild wheat, barley, and lentils grew in abundance, and humans learned to cultivate them deliberately. They planted seeds, watered fields, and harvested crops, creating reliable food supplies for the first time in history. With domesticated crops came domesticated animals. Goats, sheep, and cattle were tamed to provide meat, milk, and hides, while dogs, already companions from hunting days, became guardians and helpers in herding. This partnership between humans, plants, and animals set the foundation for a new way of life. For the first time, humans could stay in one place, building permanent villages rather than following herds. Settlements grew into towns, and towns into cities. Agriculture allowed surpluses, and surpluses allowed specialization. Not everyone needed to hunt or farm. Some could craft tools, shape pottery, weave textiles, or develop trade. Leaders emerged to organize societies, priests to interpret the will of gods, and warriors to protect resources. From this foundation rose the first great civilizations: Sumer in Mesopotamia, the Nile Valley in Egypt, the Indus Valley in South Asia, and the Yellow River civilization in China. Each took the raw power of agriculture and transformed it into social structures, economies, and cultures that still shape us today. But agriculture was not just a shift in survival, it was a shift in imagination. The ability to grow food on demand gave humans control over their environment in ways no other species had ever achieved. Rivers were harnessed with irrigation systems, forests were cleared for farmland, and granaries stored food for seasons of scarcity. Temples and monuments rose alongside fields, symbols of human ambition stretching toward the heavens. Writing systems emerged to record harvests and trade, and with writing came history itself. Before agriculture, stories lived only in memory and speech. After agriculture, they could be etched in clay, carved in stone, or inked on papyrus. Civilization was born not only from wheat and cattle, but from the written word, the foundation of culture and identity. The agricultural revolution also reshaped humanity's relationship with power. In hunter-gatherer societies, resources were shared among small groups, and leadership was often fluid. In agricultural societies, land became wealth, and wealth became power. Those who controlled fertile fields and water controlled the destiny of entire communities. Hierarchies formed, class divisions widened, and inequality became embedded in social structures. Kings and pharaohs rose, backed by armies and justified by religion. The first empires were built not by warriors alone, but by farmers whose harvests sustained the state. In this way, the plough was as important as the sword in shaping human history. Yet, agriculture was a double-edged blade. While it brought stability, it also tied humans to labor and vulnerability. Farmers worked harder and longer than many hunter-gatherers, bound to cycles of planting and harvest. They became vulnerable to droughts, floods, and pests. Entire civilizations could collapse when crops failed. Diseases spread more easily in dense populations, and domesticated animals carried germs that leapt into human hosts. Epidemics that later ravaged societies were seeded in this new intimacy between humans and animals. The agricultural revolution brought abundance, but it also brought fragility, locking humanity into a contract with the land that demanded both toil and resilience. Despite these costs, agriculture spread across the globe, adapting to different climates and resources. In the Americas, maize, beans, and squash became staples. In Asia, rice paddies transformed landscapes, feeding millions. In Africa, sorghum and millet thrived in savannas, while yams flourished in rainforests. Each region developed its own crops and techniques, weaving local environments into cultural identities. From terraced fields in the Andes to irrigation canals in Mesopotamia, humans bent the earth to their will, leaving lasting marks still visible today. The rise of agriculture also fueled cultural revolutions. Surplus food allowed for art, music, and science to flourish. Stone circles, ziggurats, and pyramids testify not only to engineering genius, but to the existence of societies stable enough to support architects, artisans, and laborers. Astronomy developed as farmers studied the skies to track seasons. Mathematics arose to measure fields and calculate harvests. Trade networks stretched across continents, exchanging not only goods but ideas, technologies, and beliefs. Civilizations did not exist in isolation. They were connected by rivers, seas, and roads, their stories interwoven in the tapestry of humanity. But with growth came conflict. As populations expanded and resources became contested, wars erupted. Cities fortified themselves with walls, and empires waged campaigns to control fertile lands. The story of agriculture is inseparable from the story of conquest. From the chariots of Mesopotamia to the legions of Rome, the armies of history marched not only for power but for grain, water, and pasture. Even today, conflicts are often rooted in struggles for resources, echoes of the agricultural revolution that first tied survival to land ownership. The agricultural revolution also reshaped the natural world in ways that continue to echo. Forests were felled, rivers diverted, soils tilled until exhausted. Species were domesticated, while others were driven toward extinction. The balance between humans and the environment shifted permanently, setting humanity on a path toward ecological dominance. The seeds of modern environmental crises, deforestation, soil erosion, biodiversity loss, were planted thousands of years ago in the first farms and fields. Humanity had become not just part of ecosystems, but a force that could remake them entirely. And yet it is impossible to ignore the profound beauty of this transformation. Agriculture created the conditions for civilizations to flourish, for art to be painted on cave walls and later in grand halls, for philosophy to question existence, for science to explore the stars. It gave us language carved in stone and songs carried through generations. It gave us cities that still stand as monuments to ambition and ingenuity. Without the agricultural revolution, there would be no Athens, no Babylon, no Giza, no Beijing, no Rome. There would be no history as we know it. Perhaps the most important legacy of the agricultural revolution is that it gave humanity a sense of permanence. For the first time, people could look beyond mere survival and imagine futures. They could build not just for themselves, but for generations. They could plant trees knowing they would not live to see them mature, carve monuments that would outlast lifetimes, and write laws to govern societies long after their authors were gone. In this sense, agriculture was not just about food, it was about vision, about humanity's ability to imagine and shape tomorrow. The agricultural revolution was not a single event, but a slow transformation, unfolding over millennia in different places and ways. Yet, Taken together, it was the most profound turning point in human history. It turned scattered tribes into nations, hunters into farmers, nomads into builders of empires. It gave rise to gods and kings, armies and artists, science and philosophy. It was the foundation of everything we call civilization. And like every great transformation in Earth's history, it was born from change, climate shifts, new opportunities, and the resilience of life. Today, as we stand in cities powered by machines and connected by digital networks, it is easy to forget that our story began with seeds, soil, and the patience to wait for harvests. But the truth is undeniable. The world we live in is the harvest of that ancient revolution. Every skyscraper, every book, every piece of music, every law and nation traces its lineage back to the first farmers who bent over fields and imagined a different future. The agricultural revolution was not just the birth of civilization, it was the birth of humanity as we know it. When humans first sowed seeds in the soil, they could not have foreseen the sprawling empires that would eventually rise from those first harvests. Yet, once food surpluses allowed populations to grow, the wheel of history began to turn faster. Small villages became city-states. City-states grew into kingdoms, and kingdoms expanded into empires that stretched across continents. With these empires came not only armies and rulers, but also the exchange of knowledge, the birth of philosophies, and the rise of sciences that sought to explain not only the earth but the heavens themselves. This was the age when humanity began to think of itself not just as tribes or towns, but as part of a broader, interconnected story, a story written in conquest and commerce, in temples and libraries, in law and mathematics. The earliest empires emerged in Mesopotamia, where rivers like the Tigris and Euphrates made fertile lands that supported dense populations. The Sumerians developed city-states like Ur and Uruk, building ziggurats that scraped the sky and writing cuneiform on clay tablets to record trade and myth. Their neighbours, the Akkadians, would unite these city-states under the First Empire, showing that power could be centralized on a scale never before imagined. Later, the Babylonians codified laws, such as the Code of Hammurabi, which declared that justice should be carved in stone for all to see. These early empires were not just about ruling land, they were about shaping order, creating systems that outlasted rulers, and gave structure to the chaos of human ambition. Egypt, with its Nile-fed fertility, produced another model of empire. Pharaohs ruled as gods on earth, their authority etched into the pyramids that still tower today. The Nile's cycles dictated the rhythm of life, and Egyptians turned this predictability into a culture of stability and grandeur. Their advances in engineering, medicine, and writing spread beyond their borders, influencing neighbors and rivals. Meanwhile, in the Indus Valley, cities like Mohenjo-Daro and Harappa rose with sophisticated urban planning, grid layouts and drainage systems that revealed a deep understanding of civic life. In China, the Yellow River nurtured dynasties that would endure for millennia, weaving philosophy, bureaucracy, and culture into one of the longest continuous civilizations in history. Each region created its own empire, but the common thread was clear. Once humans could harness the land, they sought to harness each other, building structures of power that carried both brilliance and brutality. As empires expanded, so did conflict. Conquest became a way of life, as rulers sought to expand their borders, secure trade routes, and control resources. The Assyrians marched with iron weapons and unmatched ferocity, creating an empire built on fear and military discipline. The Persians, by contrast, expanded with a policy of tolerance, allowing conquered peoples to keep their customs and religions, provided they pledged loyalty to the great king. This blend of power and pragmatism created one of the largest empires in ancient history, stretching from India to Greece. But no matter how vast, every empire faced the same truth. Expansion brought riches and glory, but also the seeds of rebellion, overextension, and eventual collapse. Empires were human-made storms, fierce and transformative, but always temporary in the endless flow of history. Beyond conquest, empires were also crucibles of knowledge. The Greeks, for instance, pushed human thought in new directions, asking questions not only of gods but of reason and observation. Philosophers like Socrates, Plato, and Aristotle laid the foundations of Western thought, exploring ethics, politics, logic, and science. Their ideas were debated in marketplaces and academies, shaping generations to come. The Greeks also celebrated art, theatre, and democracy, experiments in governance that still resonate today. Their empire, under Alexander the Great, spread these ideas across lands as far as India, blending cultures in a fusion known as the Hellenistic world. Knowledge, like empire, could not be contained by borders. It traveled with armies, merchants, and scholars, planting seeds in foreign soil. Rome took these lessons and built an empire of unparalleled scale in the Western world. Roman roads stretched across Europe, the Middle East, and North Africa, connecting cities and enabling trade, travel, and communication on a scale never seen before. Their laws codified rights and duties, creating systems of governance that became the backbone of modern legal traditions. Their engineering achievements, arches, aqueducts, amphitheatres, still stand as monuments to ambition and skill. But Rome was more than infrastructure. It was a melting pot of peoples and cultures, a stage where gladiators fought, philosophers debated, and emperors wielded absolute power. At its peak, Rome was not just an empire of land, but of imagination, shaping ideals of citizenship, law, and identity that echo through centuries. While Rome ruled the Mediterranean, other empires flourished elsewhere. In the Americas, the Maya charted the heavens with astonishing accuracy, building cities aligned with celestial events. The Inca created roads and terraces that conquered mountains, weaving a network across the Andes. The Aztec built Tenochtitlan, a city of temples and canals that dazzled Europeans when they first arrived. In Africa, the kingdom of Kush, Carthage, and later Mali thrived through trade in gold, salt, and ideas, connecting sub-Saharan Africa to the Mediterranean and beyond. Empires rose wherever humans settled, each a reflection of their environment, resources, and ambitions. Knowledge was perhaps the greatest inheritance of these empires. Libraries such as Alexandria collected scrolls from across the known world, preserving wisdom from Egypt, Mesopotamia, Greece, and beyond. Mathematics advanced in Babylon and India, where the concept of zero would eventually revolutionize calculations. Chinese scholars developed paper, gunpowder, and the compass, inventions that would change the trajectory of global history. Islamic scholars during the Abbasid Caliphate translated ancient texts, preserved knowledge, and expanded it, making breakthroughs in medicine, astronomy, and philosophy. These currents of learning flowed through trade routes like the Silk Road, carried by merchants, pilgrims, and wanderers. Empires rose and fell, but ideas outlived them, flowing like rivers across the centuries. Religion also rose to prominence during this time, binding societies together under shared beliefs. Hinduism and Buddhism spread across Asia, shaping cultures and philosophy. Judaism, Christianity, and Islam emerged in the Middle East, each offering not just faith but frameworks for community, law, and morality. Empires often embraced religion as a tool of unity and legitimacy, but religion also outlasted empires, creating identities and traditions that transcended borders. Pilgrimages, sacred texts, and rituals became as powerful as armies in shaping human history. The age of empires was both a triumph and a tragedy. It created beauty, knowledge, and culture on scales that still inspire awe, but it also unleashed wars, oppression, and destruction. Millions labored in fields, built monuments under coercion, or fought in endless wars of expansion. Yet it was within this crucible of power and suffering that humanity forged the foundations of the modern world. Roads that once carried legions would one day carry merchants and travelers. Laws carved by kings would influence democracies centuries later. Ideas debated in ancient forums would inspire revolutions. Empires died, but their legacies lived on. Perhaps the most enduring legacy of this period was the realization that humanity's story was global. Empires connected distant lands, trade routes carried not only goods but diseases and innovations, and cultures mixed in ways that created both tension and transformation. The human story was no longer one of isolated tribes, but of interwoven destinies. And while no empire proved eternal, the knowledge and connections they fostered created a foundation for the next great leap. The scientific revolutions, the industrial revolutions, and ultimately the global civilization of today. In the sweep of Earth's history, the Age of Empires is but a chapter. Yet it is the chapter in which humanity truly began to see beyond horizons, to explore, to question, to innovate, and to connect. It was an age of ambition and imagination, where humans for the first time began to think not only about survival but about legacy. And though empires crumbled, their stones and stories remain, whispering across time that humanity's greatest strength has always been its ability to dream larger than the borders of its world. As the echoes of ancient empires faded and the medieval world endured centuries of turbulence, humanity found itself at a turning point. In Europe, once fragmented by wars, plagues, and feudal struggles, a remarkable transformation began to stir. This transformation would later be called the Renaissance, meaning rebirth because it revived the spirit of inquiry, creativity, and ambition that had once defined civilizations like Greece and Rome. But it was more than just a revival. It was a reinvention, a moment in history when humans began to break the boundaries of tradition and look outward, inward, and upward with renewed curiosity. Art, science, literature, and exploration surged, and with them, humanity took its first steps into the modern world. The Renaissance did not arrive overnight. It was seeded by centuries of preserved knowledge, carried forward by scholars in the Islamic world who had translated Greek and Roman texts, expanded them, and shared them through trade routes and intellectual exchanges. When this knowledge filtered back into Europe, it ignited sparks in the minds of thinkers hungry for new ways of seeing the world. Italian city-states like Florence, Venice, and Milan became the epicenters of this awakening, fueled by wealth from trade and patronage from powerful families like the Medicis. Artists, writers, and scientists found themselves in an environment that celebrated innovation, encouraging them to push beyond old boundaries. In art, figures like Leonardo da Vinci and Michelangelo redefined what it meant to capture the human spirit. Da Vinci, with his insatiable curiosity, filled notebooks with sketches not only of paintings but of machines, anatomy, and flight, blending art and science in ways that revealed the unity of knowledge. Michelangelo's sculptures and frescoes embodied the Renaissance ideal of human potential, portraying the body not as frail but as divine in form and power. Through their works, humanity began to see itself not as insignificant but as capable of greatness, a shift in perspective that rippled through culture and thought. But the Renaissance was not limited to art. It was equally an age of scientific awakening. Thinkers like Copernicus dared to challenge centuries of belief by proposing that the Earth was not the center of the universe, but merely one planet orbiting the Sun. This heliocentric model was radical, unsettling the very foundations of religious and philosophical thought. Galileo later took this further, using telescopes to observe moons orbiting Jupiter, mountains on the Moon, and phases of Venus, all evidence that the cosmos was far more complex than dogma had suggested. These discoveries did not come without resistance. Institutions rooted in tradition sought to silence such voices, but the tide of inquiry could not be stopped. The Renaissance had planted seeds of doubt, and with them the seeds of science. The printing press, invented by Johannes Gutenberg in the mid-15th century, accelerated this revolution. For the first time in history, knowledge could be reproduced and distributed on a mass scale. Books that once required months of painstaking copying could now be printed quickly and shared widely. This democratized learning, allowing ideas to spread beyond elites and clergy into the hands of ordinary people. It fueled literacy, debate, and dissent, empowering reformers like Martin Luther, whose theses nailed to a church door sparked religious upheaval. The world was no longer confined to the few who held power over knowledge. It was opening to the many. At the same time, exploration extended humanity's horizons beyond imagination. Driven by ambition, greed, and curiosity, European powers launched voyages across oceans. Christopher Columbus sailed westward, believing he would reach Asia, but instead stumbled upon the Americas. Vasco da Gama reached India by sea, linking Europe directly to the spice-rich markets of the East. Ferdinand Magellan's fleet circumnavigated the globe, proving definitively that the Earth was not only round but vast and interconnected. These voyages shattered old maps, rewriting geography and altering the balance of power in the world. The age of exploration was as much about conquest as it was about discovery. While it expanded horizons, it also unleashed colonization, exploitation, and devastation upon indigenous peoples. Empires seized lands, resources, and labor, fueling the rise of Europe as a dominant power, but at great human cost. Yet the exchanges, plants, animals, technologies, and ideas forever reshaped the world. The Columbian Exchange brought potatoes, tomatoes, and maize to Europe, while horses, wheat, and diseases crossed to the Americas. Globalization, with all its complexities, began in earnest during this age. binding continents together in networks of trade, culture, and conflict. Back in Europe, the Renaissance spirit fostered not just exploration of lands, but exploration of ideas. Humanism, a philosophy emphasizing the value of human experience and reason, challenged the dominance of purely religious worldviews. Writers like Erasmus, Petrarch, and Machiavelli grappled with politics, morality, and the nature of power in ways that laid the foundation for modern thought. Shakespeare's plays captured the range of human emotions and ambitions, resonating across time with their exploration of love, betrayal, and destiny. The Renaissance was not just a movement of elites, it was a cultural shift that touched every level of society, reshaping how people understood themselves and their world. Science, too, advanced beyond astronomy. Andreas Vesalius mapped human anatomy with unprecedented accuracy, while William Harvey described the circulation of blood. Mathematics expanded with the work of Descartes and others, laying the groundwork for calculus and modern physics. Francis Bacon and later Isaac Newton emphasized experimentation, observation, and laws of nature, forging what would become the scientific method. These breakthroughs created a framework for understanding the universe, not through superstition or tradition, but through evidence and reason. The consequences would be revolutionary, sparking an age of discovery not just on Earth but eventually beyond it. As Europe surged ahead, other civilizations also thrived, though often overlooked in Western narratives. The Ming Dynasty in China fostered art, literature, and naval expeditions under Admiral Zheng He, whose fleets dwarfed those of European explorers. The Ottoman Empire controlled vast trade routes, blending cultures and preserving knowledge. In Africa, the city of Timbuktu became a center of scholarship, its libraries housing thousands of manuscripts. The Renaissance and Age of Exploration were global phenomena, not confined to one continent, but influenced by exchanges across the world. Humanity was becoming a planetary species, its stories, struggles, and innovations intertwined. Yet, the Renaissance was not purely a golden age. The very forces that propelled it, ambition, curiosity, and expansion, also sowed conflict. Wars erupted between empires competing for colonies, resources, and influence. The exploitation of indigenous peoples and the transatlantic slave trade marked dark chapters that revealed the cost of progress when driven by greed. Even the spread of knowledge created turmoil, as religious reforms fractured Europe and sparked bloody conflict. The Renaissance, like every era, was a mixture of brilliance and brutality, a reminder that human progress is never simple or without consequence. But perhaps its greatest gift was a new vision of humanity's place in the universe. For millennia, humans had seen themselves as the center of creation, bound by tradition and fear of the unknown. The Renaissance dared to suggest otherwise, that humans could question, create, and explore without limit. It was an age of possibility, where the boundaries of art, science, geography, and philosophy expanded beyond anything the world had known. It set the stage for revolutions, scientific, industrial, political, that would follow, forever altering the trajectory of civilization. The Renaissance and the Age of Exploration were not isolated events but catalysts. They transformed humanity from a species rooted in tradition to one reaching for knowledge, power, and connection across the globe. They taught us that the world was far larger than we had imagined, that the heavens could be studied, that art could capture truth, and that human potential was boundless when curiosity was unleashed. It was the moment when humanity truly began to stand at the threshold of the modern age, no longer bound by what was known but driven by what could be discovered. For most of human history, progress moved slowly, measured in centuries or even millennia. A new tool, a farming method or a navigation technique, might take generations to spread across societies. But in the late 18th century, a seismic transformation began to accelerate the pace of change. It started quietly in Britain, with inventions that seemed practical at first: better looms for weaving, pumps for draining mines, engines for lifting water. Yet these machines, simple at the outset, unleashed a revolution so profound that it altered not only economies, but the very structure of human life. The Industrial Revolution was not merely an advance in technology, it was a reordering of society, nature, and humanity's relationship with both. At its heart was energy. For thousands of years, humans had relied on muscle, human and animal, to plow fields, carry goods, and power tools. Windmills and water wheels supplemented this effort, but their power was limited by weather and geography. Then came coal, buried for millions of years beneath the earth, holding the energy of ancient forests compressed into black rock. When humans learned to burn coal not just for heat but for driving machines, the world changed. The steam engine, perfected by inventors like James Watt, transformed coal's potential into mechanical power that could run factories, pump mines, and move locomotives. Suddenly, energy was no longer bound by rivers or seasons. It could be summoned at will, fueling an explosion of productivity. Factories rose where workshops once stood. Spinning machines and power looms revolutionized the textile industry, turning cloth production from a household task into an industrial powerhouse. The demand for cotton surged, linking Britain's mills to plantations in the Americas and colonies around the globe. Iron and steel industries expanded, producing the bones and sinews of a new mechanical world. Railways carved lines across landscapes, shrinking distances and making trade, travel, and communication faster than ever imagined. Cities swelled as people left rural villages to work in factories, drawn by the promise of wages but often trapped in grueling labor and crowded living conditions. The Industrial Revolution built wealth, but it also built slums, pollution and hardship, a paradox of progress that defined the age. Transportation itself became a revolution within the revolution. Steamships plied oceans, turning months-long voyages into weeks. Railroads opened interiors of continents, stitching together nations and empires. Canals, bridges, and tunnels multiplied, bending geography to human will. This expansion did not simply move goods, it moved ideas, cultures, and ambitions, weaving humanity into tighter networks than ever before. The world became smaller, interconnected in ways that made isolation almost impossible. The Industrial Revolution did not just create machines, it created a new global rhythm, one driven by speed, exchange, and relentless growth. Alongside industry came science. Chemistry advanced with the development of new dyes, medicines, and explosives. Electricity, once a curiosity of sparks and static, was harnessed by innovators like Michael Faraday and later Nikola Tesla, giving rise to motors, telegraphs, and lighting. Biology progressed as Charles Darwin published On the Origin of Species, a work that challenged humanity's place in nature and offered a new lens on life itself. The scientific method, refined in earlier centuries, now found direct application in solving industrial problems, creating a feedback loop where discovery fed innovation and innovation demanded further discovery. Humanity had entered a self-reinforcing cycle of progress, unlike anything in history. But progress came with costs. The very coal that fueled factories darkened skies and choked cities with soot. Rivers became polluted with industrial waste, landscapes scarred by mines and mills. Workers, including children, labored in dangerous conditions for long hours, often with little regard for safety or dignity. The promise of wages brought millions into cities, but the reality was overcrowding, disease, and poverty for many. Social tensions grew as industrial wealth concentrated in the hands of factory owners and investors, while laborers struggled for fair treatment. Out of these tensions arose new political and social movements, calls for labor rights, unions, and eventually revolutions that demanded justice in the face of exploitation. The Industrial Revolution was not only an economic transformation but a social upheaval, reshaping power structures and sparking debates about justice that still continue today. The revolution also altered the balance of power between nations. Industrialized countries gained immense advantages over those that remained agrarian. Britain, with its early lead, built a global empire powered by industry, projecting influence through its navy and dominating trade routes. Other nations soon followed. Germany, France, the United States, and Japan industrialized rapidly, competing for markets, colonies, and resources. Industrial might became synonymous with national strength, fueling rivalries that would erupt into wars in the 19th. Technology became not only a tool for progress, but a weapon of dominance, reshaping geopolitics on a global scale. Despite the hardships and conflicts, the Industrial Revolution unlocked human potential in ways never seen before. Education expanded as societies realized the need for skilled workers and literate populations. Printing presses churned out newspapers and books for growing audiences hungry for information. Scientific societies flourished, and inventions multiplied from photography to anesthesia, from typewriters to bicycles. For the first time, ordinary people could access tools, goods, and services that once belonged only to elites. Middle classes grew, cultures diversified, and life expectancy slowly improved with advances in medicine and sanitation. The Industrial Revolution created suffering, but it also created opportunity. and millions seized it to build new lives. By the late 19th century, the revolution had entered a second phase, often called the Age of Steel and Electricity. Steel replaced iron as the backbone of industry, stronger and more versatile for railways, bridges and skyscrapers. Electricity lit homes, powered machines, and connected people through telegraphs and telephones. The internal combustion engine arrived, leading to automobiles and airplanes. In a few short generations, humanity had gone from horse-drawn carts to machines that could cross oceans and skies. Time itself seemed to accelerate, each decade bringing inventions that rewrote daily life. The Industrial Revolution was no longer just an event. It was a condition of existence, a force that reshaped what it meant to be human. Yet perhaps its most profound impact was psychological. For the first time, humans realized they could bend not just land or rivers, but the very forces of nature to their will. Energy, once fleeting, was now harnessed in engines and wire. Production, once slow, became measured in tons, miles, and horsepower. Cities rose with skylines of steel, symbols of ambition reaching toward the heavens. The sense of possibility was intoxicating, but so too was the realization of vulnerability. The same machines that built could also destroy. The same power that illuminated cities could power weapons. The Industrial Revolution gave humanity godlike tools, but it left open the question of how those tools would be used. In the grand sweep of Earth's history, the Industrial Revolution was a blink of an eye, barely 2 centuries of change in a planet billions of years old. Yet its impact rivals the asteroid that ended the age of dinosaurs, not in destruction but in transformation. It was the moment when humanity's destiny broke free from natural rhythms and began to follow a self-made trajectory. From the smoke-filled factories of Manchester to the glowing lights of New York, from the mines of Germany to the railroads of India, the Industrial Revolution left no corner of the world untouched. It was both the triumph of human ingenuity and the beginning of challenges that still define our age: inequality, environmental degradation, and the question of whether progress can be sustained. The age of machines was not the end of history, but the prelude to modernity. It laid the foundations for the digital, nuclear, and space ages that would follow. It showed that humanity could dream, build, and transform at a scale once unimaginable. But it also warned that power comes with responsibility, and that every revolution carries consequences. The Industrial Revolution was not simply about machines. It was about what humans chose to do with them. In that choice lies the legacy of the age that turned coal and steam into the engines of civilization. The 20th century opened with a mixture of promise and tension. The Industrial Revolution had gifted humanity unprecedented power, but with that power came rivalries, ambitions, and insecurities. Nations armed with factories, steel, and electricity competed for dominance, carving up territories, hoarding resources, and racing to display their strength. Empires stretched across continents, their colonies feeding raw materials into industrial machines and their people conscripted into armies. Yet beneath the facade of progress lay fractures. Ethnic tensions, nationalist movements, and political unrest simmered across Europe, Asia, and beyond. It was only a matter of time before these fault lines erupted, and when they did, the result would be unlike anything humanity had ever witnessed. The First World War, beginning in 1914, was the spark that turned industrial might into industrial slaughter. It was a conflict born from entangled alliances, imperial ambitions, and nationalist fervor, but once unleashed, it revealed the terrifying potential of modern technology. Machine guns cut down soldiers in waves, artillery shells turned landscapes into wastelands, and poison gas choked trenches with horror. For 4 years, Europe became a charnel house, where millions perished in muddy trenches stretching from the North Sea to the Alps. The old romantic visions of warfare, the cavalry charge, the noble duel, were obliterated by mechanized death. The Great War, as it was called, marked the end of illusions. It showed that progress could just as easily build killing machines as it could hospitals or schools. When the war finally ended in 1918, it left scars not only on landscapes but on psyches. Nations lay in ruins, economies shattered, and societies traumatized. The Treaty of Versailles imposed heavy burdens on Germany, planting seeds of resentment that would later bloom into catastrophe. Meanwhile, empires collapsed. The Austro-Hungarian, Ottoman, and Russian, all swept aside by the tides of war and revolution. In Russia, the Bolsheviks seized power, birthing the world's first communist state, a development that would redefine global politics for the century to come. The world, once held together by empires and monarchies, was now a fractured place, searching for stability but teetering on the edge of further upheaval. The interwar years were a paradox of despair and innovation. The Roaring Twenties brought jazz, cinema and aviation feats, symbolizing optimism and cultural vibrancy. But the Great Depression of the 1930s shattered economies worldwide, plunging millions into unemployment and poverty. Desperation created fertile ground for extremism. In Germany, Adolf Hitler and the Nazi Party rose by promising restoration and revenge. In Italy, Mussolini established fascism, blending nationalism with dictatorship. Militarism surged in Japan, where expansionists dreamed of dominating Asia. The world was drifting toward another conflict, and this time, the scale would be even greater. The Second World War erupted in 1939 when Germany invaded Poland, drawing Europe once again into the abyss. But unlike the First World War, this conflict was truly global. Battles raged not only across Europe but in Africa, Asia and the Pacific. Tanks rolled across fields, aircraft darkened skies, and navies clashed on vast oceans. Civilians became targets, cities bombed to rubble, and entire populations displaced or annihilated. The Holocaust, the systematic extermination of 6 million Jews and millions of others, deemed undesirable by the Nazi regime, revealed the depths of human cruelty. This genocide was industrialized, carried out with bureaucratic precision, a chilling reminder that modernity could be harnessed for evil as much as for good. The Allied powers, Britain, the United States, the Soviet Union and others, faced the Axis forces of Germany, Italy and Japan in battles that spanned the globe. The war demanded total mobilization. Factories produced weapons instead of goods. Women entered workforces in unprecedented numbers, and propaganda rallied entire populations. From the beaches of Normandy to the deserts of North Africa, from the jungles of Burma to the islands of the Pacific, the world became a battlefield. It was a war not just of armies but of ideologies, democracy against fascism, freedom against tyranny. Yet even the victors bore immense costs, with tens of millions of lives lost and entire cities turned to ash. And then came the atomic bomb. In August 1945, the United States dropped nuclear weapons on the Japanese cities of Hiroshima and Nagasaki, instantly obliterating tens of thousands of lives and unleashing radiation that would haunt survivors for decades. The mushroom cloud became the ultimate symbol of the atomic age, a stark demonstration that humanity had unlocked a power capable of ending civilization itself. The bomb ended the war, forcing Japan's surrender, but it also marked the beginning of a terrifying new reality. Humans now possessed the means to annihilate their own species. The aftermath of World War II reshaped the globe. Europe lay devastated, its cities in ruins and its empires crumbling. The United States and the Soviet Union emerged as superpowers, locked in a Cold War that divided the world into competing spheres of influence. The Iron Curtain fell across Europe, separating East from West, communism from capitalism. Proxy wars erupted in Korea, Vietnam and beyond, as each side sought to spread its ideology without triggering direct nuclear conflict. The arms race escalated, with bombs growing larger and more destructive, until the power to destroy the planet many times over rested in silos and submarines. The shadow of nuclear annihilation hung over humanity, a constant reminder of the thin line between survival and extinction. Yet, the atomic age was not solely about fear. It was also about exploration, innovation, and a strange kind of optimism. Nuclear power promised energy too cheap to meter, while rockets designed for war were repurposed to reach space. The launch of Sputnik in 1957 and the Apollo missions that followed symbolized humanity's dual capacity for destruction and discovery. The same science that split the atom also illuminated galaxies, peered into cells, and expanded human knowledge at breathtaking speed. The atomic age was thus a paradox, a time of existential dread and unprecedented progress, when humanity walked a tightrope between annihilation and advancement. Culturally, the world grappled with the consequences of 2 world wars and the looming threat of a third. Art, literature, and music reflected the anxieties of the time. Novels like 1984 and Brave New World warned of dystopian futures, while abstract expressionism and jazz broke conventions in search of new meaning. Civil rights movements surged, decolonization swept across Asia and Africa, and new nations emerged from the wreckage of empires. The wars had revealed both the depths of human cruelty and the heights of human resilience. inspiring generations to demand justice, equality, and peace. The world at war and the atomic age were defining crucibles of modern humanity. They showed the catastrophic consequences of unchecked ambition and ideology, but also the resilience of societies to rebuild, reimagine, and strive for better futures. The wars transformed geopolitics, redrew maps, and shattered illusions of invincibility. The atomic bomb shattered illusions of safety, reminding all that progress carried risks as great as its rewards. Yet within the ashes of destruction, seeds of progress also sprouted. International institutions like the United Nations were founded, aiming to prevent future conflicts. Global cooperation became not just an ideal, but a necessity in a world armed with apocalyptic power. Looking back, the wars of the 20th century and the dawn of the atomic age were not merely tragedies, but turning points. They forced humanity to confront the question of survival in ways never before imagined. Could nations learn to coexist, or would they destroy themselves in fire and fallout? Could the tools of war be transformed into tools of peace? These questions defined an era, shaping every decision in politics, science, and culture. And though the Cold War would last decades, the truth remained: humanity had crossed a threshold, and there was no going back. The machine age had given way to the atomic age, and with it came both the promise of a brighter future and the shadow of the darkest possible end. When the 20th century tipped into its second half, the scars of 2 world wars still marked the Earth, but something new began to capture humanity's imagination. For the first time, the horizon was no longer the ocean or the battlefield. It was the infinite expanse of space. At the same time, closer to home, machines began to shrink into something invisible yet transformative. Information, code, and circuits that would one day fit in the palm of a hand, but hold the power of empires. Together, the space age and the digital revolution reshaped the human story, breaking boundaries of geography, speed, and imagination. The space age began with a shock in 1957, when the Soviet Union launched Sputnik, a small metallic sphere that beeped its way across the skies. It was a simple machine, but its meaning was immense. Humanity had placed an object in orbit around Earth. For the first time, the planet was not just a cradle, but a launch pad. The Cold War rivalry between the Soviet Union and the United States turned space into a new arena for competition. But behind the politics, a deeper truth emerged. Space was not just another frontier, it was the ultimate frontier. It was the ultimate frontier. If humans could escape Earth's gravity, nothing seemed impossible. The early years of the space race were a rapid-fire series of firsts. The Soviets sent the first living creature, a dog named Laika, into orbit. Soon after, Yuri Gagarin became the first human to circle the Earth, his name immortalized as a pioneer of the cosmos. The United States responded with Project Mercury, Gemini, and finally Apollo, programs that culminated in the Apollo 11 mission when Neil Armstrong set foot on the moon and declared it a giant leap for mankind. Humanity collectively looked upward and realized that a dream as old as time walking among the stars was now real. The moon landing was not only a victory in the Cold War, but a victory for imagination, proving that even celestial bodies could be reached by will and science. Yet the space age was never just about rockets. It was about vision. Satellites began to transform daily life, carrying signals for communication, navigation, and observation. Weather forecasting became more accurate. Global television broadcasts became possible, and the Earth itself was seen from space in photographs that changed how humanity perceived itself. The famous Earthrise and Blue Marble images showed a fragile planet suspended in darkness, a single home without borders, vulnerable and beautiful. These images fueled environmental movements, philosophical debates, and the sense that humanity was, in fact, one species sharing a single world. Space redefined not only where we could go, but who we were. But while rockets reached upward, another revolution was happening in laboratories and offices, one that would reshape life even more profoundly. This was the digital revolution, the dawn of computers, code, and the manipulation of information at unprecedented speed. The roots of this revolution stretched back to World War II, when massive machines like ENIAC performed calculations for ballistics and cryptography. But in the decades that followed, these machines shrank, sped up, and spread outward, moving from government labs to universities, corporations, and eventually homes. At the core of the digital revolution was the transistor, a tiny device invented in 1947 that replaced bulky vacuum tubes. Transistors made computers smaller, faster, and more reliable. Soon after came the integrated circuit, packing multiple transistors into a single chip, laying the groundwork for microprocessors. With this leap, computers transitioned from room-sized behemoths to desk-sized machines and eventually handheld devices. Moore's law, the observation that computing power seemed to double every 2 years, proved prophetic as the pace of progress became exponential. The implications of this were staggering. Information once locked in libraries or handwritten ledgers could now be stored, processed, and transmitted at lightning speed. Businesses began to digitize operations, governments automated records, and scientists used computers to model everything from weather patterns to molecular structures. The rise of the internet, born from military and academic networks in the 1960s and 1970s, connected computers into a vast web of communication. By the late 20th century, the World Wide Web transformed this web into a global community, opening access to information, commerce, and social connection on a scale unimaginable before. The space age and the digital revolution were intertwined. Satellites launched into orbit relayed signals that fueled the growth of telecommunications, television, and later the internet. Digital systems guided rockets and spacecraft, turning exploration into precise engineering rather than trial and error. Together, they redefined what speed, distance, and knowledge meant. A message could travel across continents in seconds. A spacecraft could send back images from Mars. A handheld device could access the sum of human knowledge while fitting in a pocket. These revolutions did not just accelerate history, they redefined its scale. Yet, as with every leap forward, there were contradictions. The space age inspired dreams of unity, but it was born of rivalry and fueled by military technologies like intercontinental ballistic missiles. The digital revolution empowered individuals with knowledge, but it also concentrated power in corporations, raised concerns about privacy, and created new forms of inequality. Technology made the world smaller, but it also made divisions more visible. The same internet that connected humanity could also spread misinformation, conflict, and exploitation. The same rockets that carried astronauts to the moon could deliver nuclear warheads across oceans. Progress, once again, proved double-edged. Culturally, these revolutions reshaped imagination. Science fiction blossomed in literature and film, envisioning futures of interstellar travel, artificial intelligence, and digital consciousness. Works like 201, A Space Odyssey, Star Trek, and The Matrix captured both hopes and fears of these new frontiers. They asked questions that technology itself could not answer. What does it mean to be human in a digital world? Could machines surpass us? Would space exploration unite us, or divide us further? These cultural reflections kept pace with the machines themselves, ensuring that technology's story was always mirrored by humanity's search for meaning. By the end of the 20th century, humanity lived in a world unrecognizable compared to the one that entered it. Men had walked on the moon, robotic probes had touched Mars, and satellites encircled Earth like a technological skin. Computers had become central to work, communication, and entertainment. The internet was spreading like wildfire, connecting billions of people and shaping a new global economy. The space age had shown that no horizon was too distant, and the digital revolution had shown that no problem was too complex for computation. Humanity was no longer bound by natural limits alone. It was limited only by imagination and choice. And yet, beneath the triumphs lingered the same question that echoed from earlier revolutions. What would humanity do with this power? Would the digital revolution empower democracy or surveillance? Would the space age become a shared human endeavor or a new field of rivalry and exploitation? These questions hung over the future unanswered, but urgent. Because what defined these revolutions was not just their tools, but the choices humans made with them. In the grand arc of Earth's history, the space age and the digital revolution were astonishingly brief, mere decades, but their impact was monumental. There were the moments when humanity looked up at the stars and inward at information, realizing that knowledge itself could be a kind of propulsion, carrying us farther than rockets and faster than light. They marked the beginning of a new epoch, where exploration was no longer about geography, but about existence itself. To look at Earth from orbit, to hold the internet in one's hand. These were the signs that humanity had crossed yet another threshold, one that would shape every chapter still to come. The story of Earth has always been one of powerful forces, volcanoes reshaping continents, asteroids wiping out entire species, ice sheets grinding landscapes into new forms. But in the last few centuries, a new force has emerged, one that rivals the might of these natural titans. That force is us. Humanity, once just another species surviving at the mercy of Earth's rhythms, has grown into something different, a planetary agent capable of altering climate, ecosystems, and even the chemistry of the air and oceans. Scientists now call this new epoch the Anthropocene, the age of humans, an era defined not by ice or fire, but by the fingerprints of a single species spread across the globe. To understand the Anthropocene, you only need to look at how dramatically humans have transformed Earth in a short span of time. Consider the atmosphere, once dominated by natural cycles of carbon and oxygen. With the burning of coal, oil, and gas, humans have injected billions of tons of carbon dioxide into the sky, pushing levels higher than at any time in the past several million years. The result has been a steady warming of the planet, the melting of glaciers, the rising of seas, and storms that grow fiercer with every passing decade. Climate change is not a distant threat. It is the daily reality of the Anthropocene, reshaping coastlines, threatening food supplies, and rewriting the rules of survival. The oceans, too, bear the scars of humanity's touch. Once seen as endless and untouchable, they have become both dumping grounds and laboratories of change. Overfishing has stripped vast regions of life, while plastic's tiny, nearly invisible particles now swirl in every sea, found even in the deepest trenches. The burning of fossil fuels has not only warmed the water but acidified it, threatening coral reefs and shell-building creatures at the foundation of marine ecosystems. For billions of people who rely on the oceans for food, the consequences are immense. The Anthropocene is not just an age of human dominance, it is an age of vulnerability, where the very systems that sustained us for millennia are beginning to falter. On land, the transformation is even more visible. Forests that once stretched endlessly across continents have been felled for timber, farmland, and cities. Grasslands have been ploughed under, wetlands drained, and deserts expanded. Today, more than half of the world's habitable land is devoted to agriculture, reshaping ecosystems into vast monocultures designed to feed billions of people. While this has sustained an unprecedented population, it has also driven countless species to extinction, with extinction rates now estimated to be hundreds of times faster than natural background levels. Scientists warn that humanity may be triggering a sixth mass extinction, one not caused by an asteroid or supervolcano, but by chainsaws, bulldozers, and pollution. Urbanization has become one of the most striking features of the Anthropocene. Megacities rise where forests once stood, glowing with electricity and buzzing with human activity. At night, satellites orbiting Earth see vast stretches of light where darkness once ruled, proof that humans have extended their presence into every corner of the globe. Roads and highways crisscross continents like veins, carrying goods, ideas, and cultures, but also fragmenting habitats and reshaping landscapes. Concrete, steel, and glass have become the new mountains of this epoch, and skyscrapers, dams, and bridges are monuments to human ingenuity as well as reminders of our power to transform. Yet the Anthropocene is not only about destruction, it is also about creation. Humans have built machines that rival natural wonders in complexity. We have altered rivers with dams that hold back entire valleys, created artificial islands visible from space, and engineered crops that can resist drought and disease. We have drilled into the crust to extract oil, gas, and minerals, leaving behind tunnels, pits, and scars that testify to our hunger for resources. We have even scattered radioactive elements across the globe from nuclear tests, leaving a permanent marker in the geological record that future civilizations or alien visitors could one day discover. What makes the Anthropocene so startling is its speed. Geological ages usually unfold over millions of years, with slow shifts in temperature, sea level, and biodiversity. The Anthropocene, by contrast, has exploded in just a few centuries, a blink of an eye in Earth's time. From the Industrial Revolution to the digital age, humanity has accelerated at a pace that no natural process can match. This rapidity has left little time for ecosystems to adapt, creating shocks and collapses that ripple outward in ways we are only beginning to understand. But within the Anthropocene lies a paradox. Humanity has become powerful enough to alter Earth, yet we remain vulnerable to the very changes we set in motion. Rising seas threaten coastal cities where hundreds of millions live. Droughts and floods challenge food systems that sustain billions. The spread of diseases accelerates in a warmer, more connected world. Our triumph as a species, our ability to dominate environments, has also become our greatest risk, because the stability we depend on is unraveling beneath our feet. Still, The Anthropocene is not a story of inevitable doom. It is a story of choice. For the first time, a species has the awareness and the tools to shape an entire epoch consciously. We can choose to continue down the path of overconsumption, ignoring the limits of Earth's systems, or we can choose to rethink how we live, build and consume. Already movements towards sustainability, renewable energy and conservation are emerging across the globe. Nations debate policies to cut emissions, companies explore cleaner technologies, and communities fight to restore forests, rivers and reefs. These efforts may seem small against the scale of change, but they mark a recognition that humanity's role is not just to dominate, but to care for the only home we have. Culturally, the Anthropocene has also reshaped identity. We no longer see Earth as infinite, we see it as fragile, finite, and shared. The iconic blue marble photograph taken from space crystallized this perspective, showing that all of human history exists on a single delicate sphere. In the Anthropocene, humanity's boundaries of tribe, nation, and culture matter less than the shared fate of one planet. The challenge is whether we can act on this realization before the damage becomes irreversible. In the end, the Anthropocene is a mirror. It reflects our greatest achievements, technology, art, exploration, and knowledge, but also our darkest tendencies, greed, short-sightedness, and carelessness. It shows that we are no longer passengers on Earth, carried along by natural cycles. We are drivers steering its future. But unlike a machine, Earth does not come with a manual. The consequences of our actions are written not in lines of code, but in forests lost, glaciers melted, and species gone forever. Whether the Anthropocene will be remembered as an age of collapse or an age of transformation depends entirely on what humanity chooses in the centuries to come. The journey through Earth's history is not just a tale of rocks, oceans, and ancient creatures. It is the story of survival against impossible odds. This planet has endured fiery beginnings, catastrophic extinctions, ice ages that froze continents solid, and impacts from space that erased entire dynasties of life. Yet, through it all, Earth has continued to evolve, adapt, and persist, reshaping itself with every upheaval. What makes this age different is that one species, humanity, now has the power to influence the planet's trajectory more profoundly than any asteroid, volcano, or shifting continent ever could. The dawn of the Anthropocene has proven that we are no longer passengers drifting through natural cycles. We are active participants writing the next chapter of Earth's story. This realization should stir both pride and humility. Pride, because humanity has achieved feats once thought impossible, walking on the moon, harnessing the atom, connecting billions of people across a digital web, and extending life expectancy to levels unimaginable for our ancestors. Humility, because these very advances carry consequences that ripple outward, destabilizing the climate, eroding biodiversity, and reshaping the natural systems that cradle life itself. Earth has never needed us to survive, but we have always needed Earth, and the stark truth is that while the planet will endure whatever comes, our survival depends on learning to live in balance with the world we've so dramatically altered. What stands out in Earth's history is its resilience. Time and again, life has bounced back after cataclysmic losses, reinventing itself in new and unpredictable forms. The extinction of the dinosaurs made way for the rise of mammals, just as earlier extinctions cleared paths for entirely new ecosystems. If humanity disappeared tomorrow, Earth would eventually heal, forests would return, oceans would replenish, and species would evolve to fill the gaps we left behind. The real question, then, is not whether Earth will survive, it is whether we will find the wisdom to survive alongside. The Anthropocene is not merely a warning, it is an opportunity. For the first time, a species has both the awareness of its global impact and the capacity to change it. Renewable energy, conservation movements, reforestation projects, and innovations in sustainable agriculture show that we are capable of shifting course. More importantly, cultural awareness is growing. People across the world are beginning to see the Earth not as an endless resource, but as a shared home, fragile and irreplaceable. The perspective gained from images like the blue marble or Earthrise reminds us that national borders, economic rivalries, and cultural differences fade into insignificance when viewed from space. We all live on the same thin shell of atmosphere, on the same spinning sphere surrounded by infinite silence. Still, change will not come easily. History shows that humanity often acts too late, only after disaster forces its hand. But unlike the asteroid that ended the age of dinosaurs, The challenges of the Anthropocene are not beyond our control. They are the results of choices. Choices about how we consume, how we build, and how we define progress. And choices can be changed. The danger lies not in the inevitability of collapse, but in the illusion that there is still plenty of time. Time, after all, is what Earth has in abundance, but humanity does not. What makes this moment so profound is its uncertainty. We are at a crossroads where the future could diverge into vastly different paths. One path leads to deeper exploitation, rising seas and a world of scarcity and conflict. The other path, though harder to follow, leads to resilience, innovation, and harmony with the natural systems that sustain life. Which path will define the Anthropocene depends entirely on us. That is the ultimate test of this era. Not whether we can dominate the planet, but whether we can live as part of it without destroying ourselves in the process. In the end, Earth is not simply a stage on which humanity's story plays out. It is a character in the story, older, wiser, and infinitely more enduring. Its voice speaks in shifting winds, crashing waves, and trembling ground. It reminds us that our civilizations are temporary, but our actions leave marks that last far beyond our lifetimes. The conclusion of Earth's story has not been written, and neither has ours. But one truth echoes across all of history: survival belongs to those who adapt. Whether humanity will adapt wisely and choose a future where both we and Earth thrive together is the unanswered question of our age. And the answer lies not in some distant tomorrow, but in the choices we make today.